Section 3.1, Positive Integer Exponents. In this section, we are going to discuss multiplying and dividing when you have positive integer exponents. Remember that an exponent tells you how many times to multiply a base by itself. So, for instance, if I have something like x to the third power, x to the third power means x times x times x. Well, as I said, in this section we are going to multiply or divide when we have positive integer exponents. So let's say that you were given x to the third times x squared, and you wanted to combine those two. Well, I know that x to the third means x times x times x. And I know that x squared means x times x. Well, putting that all together, I have x times x times x times x times x. So I have x to the fifth power. So when I am multiplying and I have positive exponents, what I'm really doing is I'm adding those positive exponents. 3 plus 2 gives me 5. The answer to this is x to the fifth power. Here's another one. If I have b to the fourth times b to the sixth, I could write out that b to the fourth, b times b times b times b, and I could do the same with b to the sixth, b times b times b 6 times, but I don't want to do all that work. What I'm going to do is I am just going to add my exponents together, and I get a final answer of b to the 10th. Now remember, this only works if I have a common base. In this particular case, I had a common base over here when I did the x's. My common base was x. Here, I had a common base of b. So then I can add together my exponents to simplify my answer. What you have to be careful with is when we have coefficients in front of the variables. Here I have 2a to the third times 4a squared. I am going to write this out all the way, what this actually means. This means 2 times a times a times a times 4 times a times a. If I wanted to simplify this, remember everything is just multiplication. So I'm going to multiply the 2 and the 4. 2 times 4 gives me 8. And I have 1, 2, 3, 4, 5. I have 5 a's. So my final answer is 8a to the fifth. So I'm going to rewrite the problem the way it was at the beginning, 2a to the third times 4a squared, because obviously we don't want to do all that work all the time. What I'm going to do is I'm going to multiply the coefficients. 2 times 4 gives me 8, but I'm going to add together the exponents. 3 plus 2 gives me 5. My final answer is, as I say, 8a to the fifth. Here's another example of the same type of problem. I have the coefficients of 3 and 5, and this is multiplication. So I am going to multiply. 3 times 5 gives me 15. I have common bases of x. I have an x to the fourth, I have an x squared. I'm going to add those exponents together. The final answer to that is 15x to the sixth. Be careful, though, if you have a problem similar to this one. 4x squared y times 9x to the third. Once again, when I go through and do that, I'm going to multiply my coefficients. 4 times 9 gives me 36. I have an x squared and an x to the third power. So the only thing that I can add there, the 2 plus the 3, I'm not going to do anything right now with this y because I don't have another y base over here in this other factor that I have. So I'm going to add together the exponents, 2 plus 3. I'm going to end up getting x to the fifth, and I still have a y, which I could put as y to the first, but generally I would just leave it that way. So the final answer is 36x to the fifth y. Remember, in order to go through and add exponents, so the bases have to be the same. So if I had 3x squared times 4y to the third power, I can go through once again and I can multiply the coefficients. 3 times 4 gives me 12. But I can't do anything with the 2 and the 3 as exponents because they have different bases. So my final answer, those are just going to stay the way they are. I'm going to have 12x squared y to the third power. So let's talk about division. Just like we did with multiplication, we can go through and write out what this means. A to the third means a times a times a. A squared means a times a. So I can write that out if I want to. And then I can go through and I can cancel some things. A divided by a cancels out. I'm just left with 1. Another a and an a cancel out. And I am just left with a final answer of a. Now this could be, I could write this again as a to the first power if I wanted to. But there's an understood 1 there anyway, so generally I would not do that. But notice now this time I have common bases of a, but I'm dividing. So now what I'm going to do is I'm going to subtract those powers. 3 minus 2 gives me 1, which I am just going to write as an a. Here's another example. If I have 15x to the fifth over 5x squared. Just like I did with multiplication, now I'm going to divide my coefficients. 15 divided by 5 gives me 3. Now I need to deal with my x to the fifth and x squared. They have common bases of x, so I'm going to subtract the 5 minus 2. 5 minus 2 gives me 3, so my final answer to this is 3x to the third power. Here's one more example. Negative 32, a to the fourth, b to the fifth, c, over 8a squared b. First thing I'm going to do is I am going to divide my coefficients. Negative 32 divided by 8 gives me a negative 4. Then I'm going to take a look at what I have common bases. I have an a and I have an a, so I'm going to subtract 4 minus 2, and I'm going to get a squared. I have a common base of b, a common base of b. There's an understood 1 with that common base of b, so I'm going to go 5 minus 1 and get 4, so that's b to the fourth. I also have a c on the top. I don't have a c at all on the bottom, so that c is just going to stay on the top, and my final answer is negative 4, a squared, b to the fourth, c. The last thing to talk about in this section is exponents with powers. So if you are given x to the third and you want to take the entire x to the third and square it, what does that equal? Remember, x to the third squared means I'm going to have x to the third times x to the third. Now, since I have common bases of x, I'm going to do what I was doing before. I'm going to add my exponents, and I'm going to get an answer of x to the sixth power. If I have something like x to the seventh, and I want to take that to the third power, that would mean x to the seventh times x to the seventh times x to the seventh. Once again, I'm going to add together those 7s, 7 plus 7 plus 7, I would get x to the 21st power. I don't want to go through and write that out all the time, so remember, if you have powers, now what you are doing is you are actually multiplying those powers. X to the third, all that to the second power, is x to the sixth, because 3 times 2 gives me my 6. The second one that I have, x to the seventh, and that to the third power, the answer is x to the 21st. 7 times 3 is equal to 21. So I'm actually multiplying those powers if I have an exponent to a power. So let's add one that also has a coefficient. Here I have 2x squared and all that to the third power. I could, if I wanted to, again, I could rewrite this. I need to take 2 to the third power, so I'm going to write it that way. And I also need to take x squared to the third power. Well, 2 to the third power is equal to 8. 2 times 2 times 2 gives me 8. X squared to the third power gives me x to the sixth because I'm going to multiply those. So I started off with this problem, 2x squared to the third power. Just remember, you have to take everything to the third power. So as I go through and do that, 2 to the third power gives me the 8. X squared to the third power gives me that x to the sixth, which is that final answer. Here's another example. 5x to the fourth and all that to the third power. In order to solve this, first of all, I'm going to take 5 to the third power. 5 to the third power means 5 times 5 times 5. That's equal to 125. And then I'm going to take x to the fourth, all that to the third power. So I'm going to multiply the 4 times the 3. I'm going to get 125 x to the 12th power. At times, I might even have something that is a fraction. If I have 3/4 squared, what that really means is 3/4 times 3/4. I can write it 3/4 times 3/4, or I could write it 3 times 3 over 4 times 4. I still get 9/16 for an answer. So if I do this also with algebra, and let's say I have a to the third b squared over c to the fourth, and everything in there is squared, I'm going to do the same thing. I'm going to take a to the third and I'm going to square it, which means I'm going to have a to the sixth because I'm multiplying those exponents. I'm going to take b squared and I'm going to square it, which means I'm going to have b to the fourth because I'm going to multiply 2 times 2. And then finally, I'm also then going to have c to the fourth, and I need to take c to the fourth and I need to square that, which means I'm going to have c to the eighth. So there is my final answer to that problem. Let's review all three ideas by having some rules that you might want to look at. So if I have common bases, and let's say I have a to the m times a to the n. When I say common bases, a and a are the common bases. If I am multiplying, all I'm going to do is I'm going to add my exponents. So this would be a to the m plus n, whatever the m plus n is. Another rule is if I am going through and I am dividing with common bases. If I have a to the m over a to the n, now I'm going to keep the common base, but I'm going to subtract those exponents, m subtract n. And then finally, the last one, if I have a to the m to the power of n, this I'm going to go through and I'm going to multiply those bases, a to the mn power. This section on simplifying expressions with exponents is critical as we go through the rest of this course. If I can help in any way, please let me know.